sometimes speciation or species change takes place because the chromosome number is different, right? And presumably then your parent species cannot breed with your offspring species. The basis for that is that, okay, let's not go into the basis for that, but the underlying assumption there is that two individuals with different chromosome numbers cannot breed. I struggled with that for a while as well, until this paper just came out this year that showed that actually, even in humans now, individuals exist with different chromosome numbers, and the offspring of these individuals are actually viable. I'll need to look up the paper, but if you're interested, you can pass me your email address, I'll send you the paper.
If I could add to that, I would just want to say that chromosomal duplication, so in other words, varying numbers of chromosomes, so whole chromosomes that are being duplicated, is actually a very important source of variation, which is used by evolution in a sense to create a lot of new species.
Changes in the size of the chromosome where one is
exactly. So there are a lot of things like when you get bits of chromosomes reversing themselves, or actually detaching, translocating to another chromosome. So I think there's a lot of ways how variation and mutation can be used to create new diversity in genes.
Perhaps just to add one more point, speciation due to changes in chromosome number is actually pretty common in plant species. It's just slightly more of a problem in animal species. And also, remember, evolution doesn't have to take place just through sexual reproduction. Evolution also takes place through asexual reproduction, and changes in chromosome number isn't a problem there.
Anyone else? I have a question. You mentioned fruit flies, which makes me happy. But another thing you mentioned was that most mutation is non-adaptive, as in, i.e., the word I think is called neutral, if I'm not wrong. So can you elaborate a bit more on that?
Okay. So to do that, you've got to understand a bit of how our genome works, how DNA, basically our genetic material, codes for the characteristics you see in us. So the simplest way in which you can understand it is that your DNA actually is transferred into the information on your DNA, the sequence of your DNA is then transferred into what we call RNA, which is then translated into protein. And the protein is basically what makes you you. Most of you is protein, I mean your flesh is protein. Even parts of you that are not protein are formed essentially by protein signaling molecules, by enzymes. But the problem is that only a very, very small part of your genome actually codes for protein. So the rest of your genome is essentially, some of them have function, but most other parts don't really have function, So changes to parts of your genome, parts of your DNA that don't result in changes in your protein have no impact at all on what you look like, how you behave, right? So that is basically what's meant by neutral. Changes to your DNA that don't have any impact on your outward characteristics. And since most of your genome is made up of non-coding DNA, then most mutations by definition would, by implication then would be neutral.
Isn't that also the case that sometimes non-coding DNA will have sort of on-off switches for genes?
Yeah, that's correct. But the proportion of these on-off switches is a very, very small proportion of your genome as well.
But, okay. Thanks. Anyone else? Sorry.
Yi Jin.
Yi Jin, are you a biology teacher?
Yeah.
Was a biology teacher?
Yeah, I was.
Was previously?
Yeah.
At what level?
JC.
JC. Yeah. I know from the experience in Singapore context, when you teach biology, how are the reactions from the class to it?
Well, I taught in a school that I taught in a pretty normal school, I think. A normal JC. So just besides the context, yeah, it's not a mission school. So most students typically have no problem at all with natural selection. In fact, that's how I first came across the idea of natural selection. And if you come across natural selection without any preconceptions, well, it makes sense. And I think most of our students are still coming to natural selection without any preconceptions.
Okay, because I don't know, during my time, even during my time, they don't cover very much in the school curriculum. And I'm not sure currently what is the status in terms of school.
You're correct. So
at what level do they introduce evolution?
right now, natural selection is first introduced at the Sec 3 and Sec 4 level. So you're right to say that quite a number of students will not come across natural selection. The question then is, should you introduce natural selection at an earlier level? I'm not so sure, because to understand natural selection properly, you must understand things like ecology. You must have developed the ability to think in abstract terms.
It's not just natural selection as a mechanism, but evolution has to be found as a whole. It's not so much nothing sense biology as separate.
Yeah, that's right.
And that evolution is the foundation of a lot of the whole biological science.
Right.
So
So
shouldn't be introducing it
earlier level. So from my experience, the implementation across schools is uneven because that depends partly on individual teachers. Because all MOE does is to give you broad syllabus guidelines. You don't in the syllabus you actually do mention that evolution is the unifying theory of biology, but you don't actually dictate how people should teach it. And I don't think we actually should dictate how people should teach
what
it.
if they use creationism in the classroom?
Then their kids will fail the exam. And if teachers see it, then well, that
No,
is
but not exam part.
correct.
3 years ago, I accidentally stumbled upon a school supplementary text called Mini Science Encyclopedia, which was actually one of the supplementary texts in many mission schools. And there was an article of Online Citizen that brought this up, which had the curriculum of Ministry of Education saying that they don't advocate that.
That's
But
right.
still, when I do a search, I think about last year, it's one of the guys supplementary text in Hao Nan, I think. Nan Hao.
Okay, so I think
Yeah, precisely. As in, it's actually one of the supplementary texts on the school book list.
so I think there are many. I hope this will satisfy you, but because I think we probably should move on after this. If you are still not satisfied, you can come and look for me after this. But because I mean the topic is supposed to be about evolution itself and not how evolution is taught in Singapore.
But I thought it's supposed to be.
Yeah, correct. So I'll answer you. So
I thought it's the idea.
yeah, correct.
And I think in terms of impacting Singaporeans.
I agree.
And
So
my child is doing Mandarin 3 next year. So
Okay.
I'm interested.
Maybe we could do this after
Yeah.
next
Let
question.
him answer.
After his answer.
So right, there are many reasons why schools choose textbooks, and especially at the primary level, schools might choose textbooks because the explanation of the material in other chapters is better. That's because evolution is not a major feature of the primary school curriculum. Teachers are probably much more concerned about, for example, how the textbook explains different types of plants, the features of plants. Probably more interested in how, I suppose, the textbook explains how levers work, for example. So that might be why teachers have chosen the textbook. Right? I really cannot go into analyzing the psychology of every individual teacher in any particular Singaporean school on their textbook choice.
No, I'm just in experience what other experience.
Okay,
Yeah.
I think we'll move on. Sorry. Next. Yes, please.
As I recall, the topic today was evolution versus creationism. And you've done a great job of presenting evolution. Great job. Perhaps you've been a little too gentle, maybe a little too diplomatic in dealing with the creationist theory. From a Western perspective, that may be an Asian trait, not necessarily bad, but for a head-on attack on the creation. As a biologist, perhaps you'd like to deal with the creationist view that the Earth was made in 4004 BC. There's a lot of geological evidence against that. The possibility of Noah putting all these species on one ark, including something like a maid species in the Amazon basin. That's something you can deal with as a biologist.
Sure, I take your point. Thanks.
Sorry, I'd just like to add on to the last part. I know I'd like to see how he transported all the parasites, all your malaria. Who were the unfortunate hosts? If you only have 2 of each.
There's a magic bowl.
Yeah, exactly. So it expands. Anyone else? Questions, please? Yes.
Just very quickly, how much information is coded in a set of genes? I mean, how big how much memory would you need to actually run a DNA as a virtual machine? Like, is it terabytes or is it exabytes?
Okay, I don't have the specific answer to that.
I'm not sure. Do you mean that number of base, the number of individual letters, how big it actually is?
Are we close to being able to effectively run inside a computer something that's alive?
Recently there was an experiment called we created an artificial vacuum.
Yes, they have created. Now they basically resynthesized the whole genome from scratch, which was by Craig Venter. Yes, they recently they basically took a genome that's already existing, but it's very pared down, very small ones. They even took out a lot of the intergenic regions, everything else, and basically resynthesized from scratch the whole genome. So I don't know where I'm going with this, but I'm just yes, smart. I swear I'm smart. So a genome size is usually about what, terabytes? No, less than terabyte. A few gig. In terms of the actual letters, and the number of letters, the total number of bases is usually about a gig or a couple of gig or something like that. It depends how many passes you do.
I suspect the data should be quite small, right? I mean, the data is not big. It's really the It's really the mechanism which is big. Right?
No, the data is small. It's extracting what you want out of it because they're all, all you end up with is a file just full of letters. You have to find out where are your genes, where are your on-off switches, what does this, you have to assemble your whole chromosomes, everything. So it's actually quite a complicated process to assemble a whole genome from just sequencing data.
If I could add on, I don't have the specific answer to that, but the line of intent behind the intent behind that kind of questioning usually is that there is so much information in DNA, even our computers can't run it. How can biological organisms run it? That to me seems to be the usual line of intent behind that kind of questioning. So I suppose the most obvious point then is that biological organisms are different from computers. Second, the amount of space. Second, the term information as used in information theory has a very different meaning from everyday use. I'm not familiar with that, but if you are, I've come across a few articles. I could send them to you if you want. And last, genome size or the amount of information packed in the genome, the amount of base pairs in the genome varies very widely. There are some organisms that have very, very tiny genomes and still manage to survive very well, which is what I think Adrian alluded to when he talked about the synthetic organism.
Is there any other questions? If not, I welcome you all to stay around. We probably usually have a few more drinks, chat, everything.